Okay, today we're going to look just a brief session to help you understand how to set up commands and to edit your environment. So some of you might find when you try to type in arm-none-eabi-gcc, it just says, well, actually, if I've typed it correctly, it will say no such command. Now, it's suggesting that you might want to install it. You can't do that on the university machines because you're not a super user. And anyhow, the problem probably isn't that it's not been installed, it's just you can't find it. So the message is currently not installed is misleading. Now, first, what we need to understand is how does the system find commands for us? So when I type in ls, what I'm actually typing is /bin ls. Now, I don't have to type in /bin ls because the system already has some information inside it which tells it where to look for particular commands. And common places are like /bin. This is my home machine, so it doesn't have a great deal in it. You'll notice on the university machines that this is a very big directory. Okay, now there are other directories. Bin, by the way, stands for binary. There's a directory user bin, a bit more in there. There are sometimes, on some systems, not all, there are sbin directories, which stands for standalone binary. And these are all executable programs. Now, the use of the name bin is just a convention. They could really be anywhere. They don't have to be in bins, but generally people tend to live by the convention. Now, the system itself has a series of variables. When I say the system, I'm actually talking about the command line interpreter, and the one I'm currently using is called bash. Okay, now the command line interpreter, bash, has a variable called path, which allows it to look for various commands. So for example, it will first look in /user local sbin, and there's nothing in there, so very few commands there. And then it will look in other places such as bin, probably a few more commands there, such as OpenOCD. Now you can actually have multiple versions of commands, and the order of your path will tell the system which one it is to prioritize. And you can find out which one is going to be prioritized by saying where is. So for example, with where is OpenOCD, there's two versions, one in /bin and one in user local bin. So those two are available. So quite often there's more than one command, and the environment can be configured for you. Now, the problem is that we have some compilers installed, and the system hasn't been told where they are. So the shell doesn't know where to look. Now, you'll actually find, and you can sometimes just find this stuff knocking around, and you look in general places like /user local, /share, /user share, so on and so forth. They're common places to put these sorts of things. User local bin is a common place too. Now in user local, we've actually got a directory called arm-none-eabi, and that's got lots of subdirectories, and within that subdirectory there's a bin directory, and there are the cross compilers. Now, they just happen to have been installed there. They could actually have been linked across, if the system administrator wanted to, into a directory in your search path so that they would be in user local bin, for example. However, they're not there. And this is quite a common problem, that it's been installed, but it's not easily or readily available. Now, we can actually run the commands directly. So I can run the GCC, the cross compiler there, and this shows us the version of it and a little bit of information and detail. Now, we could, of course, just always type in that full version of the command each time. A little boring, really. So much better to change the way that the shell interacts with the system through editing the path file so that it can find that directory and those binaries easily. Now, in order to do that, we need to edit a file which is in our home directory. So I'm just going to type in cd on its own, and that will take us back to our home directory. And there's a file called .bashrc. And bashrc, it's been very slow, this machine at the moment. That's it. Bashrc is RC, I think, stands for run commands, but it's not entirely clear. And this is every time that bash runs or a subshell is run, it will run this. And this sets up things like my prompt and how long a list of commands it will remember, my history list, and other various variables that can be set up. So I'm going to edit that now. Exclamation mark dollar just means use the last parameter on the previous command line, and we'll now edit this file using Emacs. And I'll go to the end of the file, and you'll notice that Emacs is smart enough that it knows that it's a shell script it's editing, and it even knows that it's bash. So we're going to edit the path variable, and we're going to set it to $path. Now this means that it will be set to whatever was previously in path. Now that's important, because if we didn't do that, the path would just be set to the one thing we'd set it to, which wouldn't be very helpful for us. And the paths are separated by a colon character, and now I'm going to use a built-in feature of Emacs to find the directory, and this just means that I'll sort of be pretty clear that I've got the correct directory. So I will now cut that, quit that command, and yank it back out. So now we've set the path variable so that we can actually have our cross compilers in it. So I'll Control-X-S, Control-X-C for quitting out, and eventually the virtual machine will hopefully that's it. Okay, so the virtual machine. Now, if I echo $path again, we'll find that it doesn't know about the new setting. Now, the reason for this is that we ran the shell that's controlling this command line interpreter prior to editing the file. So what we need to do now is we're going to run that file, and then up arrow a couple of times, and now we've got that command there. And if I type in arm-none, I can get all of the cross-compiler tools, bin utils, the cross-compiler, and various other bits and bobs. Just out of interest, the name itself is significant. So the first part is the processor, so it's an ARM processor. None is the operating system, so we've got no operating system on our board. EABI stands for Extended Application Binary Interface, which is the ARM schema or interface or protocol which allows binary files to run, to pass parameters, to be able to start up and stop correctly. So these are important things. So for example, you will probably find, if you say where is GCC, there is GCC on the system, but that probably is a link to say no to that x86. It's probably a link to these particular commands, and this is that it's an x86 64-bit Linux GNU compiler and bin util set. Now, because we are not doing cross-compilation, we don't generally need to know that. We just need to know it's GC, it runs and works on this system. However, once you start doing cross-compilation, these things become important. So you need to know, is it ARM? Is it running Linux? Does it run Windows? What exactly are we dealing with? So these things become important. Now later on you'll find, for example, other lecturers might say, hey, there's this really great set of tools for forensics or for embedded systems development on the Linux system, and they'll tell you where the directory is, and now you should know how you will be able to find those tools and then add them to your path, so that you can use them. And any new terminal that I open will instantly get that new path. So, and be careful, the way it's typed there is important. If you miss out the leading slash, it will stop being an absolute path name, and it will then try to look in your local directory for something called /user, which it probably won't find, and it won't complain. It will just say still can't find the command. Okay, right, I hope that helps out. So there we are.